Okay, we'll have a look at this question. So in the given figure, so this is our figure here, the angle CAB. So remember, an angle is always going to have three parts. So we have, in this case, it's CAB, and the angle itself will always be on the middle point. So each of these letters represents a point. So we have the angle CAB. So we've point C, point A, and point B. And it tells us this other angle ABD. So we'll just identify the angles. So A, B, and D. So we're talking about this angle here and this angle here are both right angles. So if they are right angles, that means they have 90 degrees. And this is what this symbol, these kind of like that, that's what it represents. That means 90 degrees. So then it tells us, so this represents a line segment. So remember, so we have a line segment, and it's A, C. So every line is made of 2 points. So this one is A, and then point 2 is C, and then when you join these together, you have a line segment. So it tells us that this line segment here is 6. So A to C is 6. So this is 6. A to B is 8. So this is 8. And then A to D is 17. So A to D. So A to D here. A to D is 17. And you read these from left to right. So you start from A to D is 17. So you've been asked to find out what's the length of this side, D to B. So D to B, so this length. So what is this length? That's what you're trying to figure out. And then it tells you to find the area of ACBD. So ACBD. So you've been asked to get the area of the whole shape, which is basically made up of two triangles. So first of all, we'll work at trying to get this side here. So if we take any right angle triangle, and let's see if we can get one here. So okay, so when we have a right angle triangle, okay, so we have, let's say this side is A, we call this side B, and this side C. So this is the longer side. So Pythagoras' theorem basically states that A squared, so this side squared, is going to be equal to this side squared added to this side squared. So that's Pythagoras' theorem. So we can use this here to figure out if we have two sides, for example, of a triangle, we can figure out the third using Pythagoras' theorem, and that's what it's kind of it's gearing you up to do here. So first of all, you have to identify like which is the longest side. So this is A in this here is the longest side. So we can say that we can see here that this is the longest side. So this side we can call this bottom part. We'll just call it B. So we're looking for B, and then we'll call this C. Okay, so A is 17. So what we can say is that 17 squared, okay, so this is A, is going to be equal to C squared, which is 8. So it's going to be 8 squared plus this unknown. So this is what we're trying to work out. So we'll just leave it as B. So B squared. So then we can just work these out. So 17 squared. So 17 multiplied by 17. That's equal to 289. So it's 289 is equal to 8 squared. So 8 multiplied by 8 is equal to 64 plus B squared. Now what we want to do is we want to get this letter, this B or this side on its own so that we can figure out what it is. Now in order to get it on its own, I have to get rid of all the numbers around it. So if we take, so we look at, so this is 64 and it's 64 plus B. So 64 is being added to it. So in order to understand what you have to do, like what do you multiply, add, divide, take away. So you look at, so this is addition. Okay, so the opposite of addition is subtraction. If it was multiplied by, the opposite of multiplication is division, the operation. And then if we have something to the power, the opposite of that is the square root. So we can see here that this is 64 plus. So we're dealing with this operation as addition. So we do the opposite of addition and we subtract. So we basically what we want to do is we want to turn this 64 to 0. So what we can do is we can minus 64. And if I minus 64 on this side of the equal sign, I have to do exactly the same on the other side. So you can kind of think of it like a balance. If I take 64 off this side, I have to take 64 off this side in order for the both sides to remain equal to each other. So 64, so plus 64 minus 64, they'll just cancel out, and you'll be left with, I'm just going to write this over here, I'm just turning it around. So b squared is going to be equal to 289 minus 64. So 289 minus 64, which is equal to 225. So b squared is equal to 225. So 225. So we're nearly there. So we just need to get rid of this power. So if I have something to the power, the opposite of that is the square root. So in order for me to get rid of or cancel out this power, I get the square root of it. And if I get the square root on this side, I have to do exactly the same on this side in order to keep both sides equal to each other. If I just square this side and leave it the way, it'll be unbalanced. So if you square a power, it gets rid of the power, so it just leaves you with b is equal to the square root of 225. So the square root of 225 is equal to 15. So we can say that b is equal to 15. And we're talking about, so this is this length here. So b is equal to 15. So we can just work that out. B is equal to 15. So, and what we can say then is that this line DB, so the line DB is equal to 15. Now what we want to do is we want to get the area of both triangles and add them together. So in order to get the area of a triangle, it's half of the base multiplied by the perpendicular height. Now, perpendicular means, so if I have a base and I have a line growing out of that base, okay, or a height growing out of that base, it'll form a 90-degree angle. So therefore, this length here is perpendicular to this base. And that's what you have to be careful when you're trying to get the area of a triangle. So the base will have a perpendicular height coming out of it. So you're always looking for that. So we can use this guy here as the base. Okay, so we can use this as the base. And the perpendicular height coming out of that base is this length from B to A, which is 8. Okay, so we can take our figures from here. So the area, so we'll just call this, let's say, triangle 1. Okay, so triangle 1 area. So this is area is equal to, so the area, so the triangle 1's area is going to be equal to 1/2 of its base. So its base is 15. So it's half of 15 multiplied by the perpendicular height, which is 8. So half of 15 is 7.5 multiplied by 8, which is going to be equal to 7.5 multiplied by 8 is equal to 60. So it's equal to 60, and it's square units. So area is always going to be in square units. So that's the area of triangle 1, and we'll call this triangle 2. Maybe if I do this in a different color. So triangle 2, so again we want to look for the base. So if we treat this as the base, then this length here is the perpendicular height. So we can say, so triangle 2 is going to area will be equal to 1/2 of the base. So we're saying that this is the base of triangle 2, so it's going to be half of 6 multiplied by the perpendicular height. So remember, the perpendicular height always has to form a right angle with the base. So the perpendicular height in this case will be this line here from A to B, which is 8 centimeters. Or sorry, 8. It doesn't actually give you the units. So it's 8. Okay, so half of 6 is 3 multiplied by 8 is going to be equal to 8 and 8 16 is 24 square units. And what we can say then is that the area of this, find the area of the whole shape. So ACBD, ACBD. So you're looking for the area of the whole shape. It's just going to be these two areas added together. So this guy and this guy added together. So if we add the two areas, so the area of ACBD is equal to 60 plus 24, which is equal to 84 square units. And that's it. So this is equal to 84 square units. And that's it. So you're just finding the area of two triangles and adding them together. And you're also using Pythagoras' theorem as well to work out the length of one of the sides. Okay, hopefully that makes sense.